All right, time to start. I'm a bit overwhelmed because I've never ever had a room that is more than full of people sitting on the floor. Welcome to this session about programming with contracts in C++20. I am Björn Fahller. I will not bore you with a long history of my career. I've been doing C++ for too long. I will mention, however, that I'm quite active in the Sweden CPP, which is an umbrella organization for the Swedish C++ user groups. So if you're visiting Sweden, get in touch. I can direct you to the local user groups so that you can geek out with like-minded people. And specifically, if you're in Stockholm, get in touch. I'm quite active there. That is my home user group. So with that out of the way, let's get started. Programming with the contracts in C++20. And I should probably have this on. Okay, so what is a contract? A brief glance at Merriam-Webster's dictionary says a binding agreement between two or more persons or parties, especially one legally enforceable. Okay, that is interesting. There are some applications to what I'm going to talk about today. A business arrangement about the supply of goods or services at a fixed price. We can give up that one. The act of marriage or an agreement to marry. I actually had no idea about that one. But then I'm not a native English speaker, so. A document describing the terms of a contract. So we sort of use the contractual terms and the actual document as interchangeable things. Okay, can be confusing if you're not careful, but that's it. Final bid to win a specified number of tricks in bridge. Any bridge players here? I don't think that is really what we're going to talk about today, though. An order or arrangement for a hired assassin to kill someone. We will come back to that one. In software design, it's a formalized agreement regarding program correctness between a user and the implementation of a component. I'm using somewhat sloppy phrasing here. The component can be a single function, it can be a class, it can be a whole library, but something that fulfills a function and someone that wants to use it. And it's a formalized agreement, and it's a formalized agreement regarding program correctness. That is, a violation of a contract is, per definition, an incorrect program. How many of you feel comfortable in using contracts in interface design day to day? Okay, I'll count 4 hands. So that means that I spent a lot of time preparing slides to go through. The basic idea was not wasted. That is good. I learned about contracts a long time ago. I was at university. I think it was the winter 91-92. We had a course in object-oriented software construction. We used this book, Bertrand Meyer's book, that explains how the iPhone programming language works. It's interesting, in 91-92, that is sort of the heydays of object orientation. There wasn't a problem under the sun that couldn't be solved super easily with object orientation. And curiously, I really don't remember what I thought about object orientation at the time, which means it probably didn't impress me much, but I really don't remember. But I do remember vividly this, chapter 7 in the book. Systematic approaches to program construction, the notion of assertion, precondition and postcondition, contracting for software reliability, class invariance and class correctness. And I will focus on the 3 on the left. Because when I learned about these, it was really this moment of, oh, can you think that way about expressing what the obligations of an implementation and a user are. I'd never thought about that. That was cool to me. And I have used it ever since, regardless of programming language that I've used. Because that is an important thing to remember, that contracts, designed by contract, it is an interface design principle. Having language support can help, but it's not a requirement. I should probably mention some people I've talked to have been confused about concepts and contracts. These are very different things. Phonetically somewhat similar, but very different things. Concepts regard types, what operations you're allowed to do on types, which types can match when and where. It's a static thing. Violating a concept means an overload set is discarded or a compilation error, whereas contracts are a runtime thing. It's about having at runtime reached an illegal state or calling something with illegal values. In my opinion, it is vastly preferable if you can achieve the constraints you want to with a type system. But if you can't, and you can't do it always, and I shouldn't say when it's impossible, but when it's unreasonable to, contracts can help. Throughout this presentation, I'm using a ring buffer as an example. It goes under many names. I once heard about a presenter who used this as an example and was stunned to hear that half the audience had absolutely no idea what a ring buffer is. So I'm going to show you. A ring buffer is a fixed size queue. Fixed capacity queue, I should say. So this one, ring buffer int of 12, it's a queue, it's circular, and it can hold exactly 12 ints. It can never grow. 12, that is its limit. And this means that if it needs to allocate any resources whatsoever, it does so at construction time, and then it's done. So we can just walk around here, push some numbers to it, we can pop some numbers from it, push some, pop a little bit, and then it just goes round and round and round, and that's it. So if you weren't familiar with what a ring buffer is, you are now. So you're educated. So let's, yes?
So that it allocates its resources at the beginning, is it always necessary?
No, I said if it allocates anything, it does at the construction time.
It might not do that.
It might not. Actually, never mind that. The important thing is that it has a fixed capacity, it cannot grow. That is the important thing. How it's implemented is completely out of scope. That is not the thing that is interesting here. So let's start contractifying this. So, a precondition. A precondition is an obligation that a caller must fulfill for the program to be correct. And preconditions typically refer to parameter values or the object state or some combination of them. It could refer to the global state, but please don't. So let's go through this. Default constructor. Do we have any preconditions on the default constructor? Sorry? Enough memory available. Would you say that the programmer that calls the default constructor has a bug if there was not enough memory available? No. So we could actually see that the heap, if that is necessary or whatever, is something that we want to expose, but we usually don't want to do that. It's messy. I would say that for a default constructor, it almost never makes sense to have a precondition. Because a precondition typically are about the object state, and the object doesn't exist before we construct it, and the parameters, and there are no parameters. One exception that I can see is if you implement, say, a singleton, you can have a precondition that you don't already have an object, but then you actually don't want a singleton, I think. So never mind that. So we normally never have preconditions on ring buffers. Exceptions can exist. Calling size then, to query the number of elements in the queue. Do we have preconditions on that? Oh, I don't see anyone thinking that we should. That is good. That is the right reaction. Yes?
This case is a template. There might be preconditions on the types, for example.
There may be preconditions on the type of the template, and those are by definition not preconditions. They are concepts or something else. It's a compile time thing. So that does not apply, but thank you for pointing it out. I could argue that n would have to be greater than 0, and I would still maintain that that is something about the type and not a runtime behavior. That is true. It is not a condition on the type of int. That is a correct observation. I agree. That would be a static assert or something else, yeah. Okay, so typically functions that query the state don't have any precondition. I can't actually remember ever having used one. Operator at or a bracket on a vector, you want to ensure that you're not outside the bounds of the container. Yes, I agree. But that is not, I would say that that is an access function to get something from it, from the container. It's not the same thing as querying how many elements there are in the vector. Those are very different things. Yes, John?
I think it might be worthwhile to say if you have a function that has no preconditions, then you can call it pretty much anytime you want to. If it has preconditions, then you can. And there are some functions like size or whatever that you need to access the thing in order to determine whether you can call other functions. So if you ask for the length or the size of the vector, and it's big enough, then you can call another function that has a precondition. So there are narrow contracts and wide contracts. Wide contracts don't have preconditions. You can call them anything.
So yeah, so John's observation, absolutely correctly, is that you can chain things. This function call can in turn call other things which may have preconditions on them. So you have degrees of contracts. You can have very wide contracts, very narrow contracts, so it's not a black and white having a contract or having no contract. Was that the way you intended me to?
What I was saying is there are some accessor functions that have no preconditions,
yes.
like the length.
Yep.
There are some that do, like Alistair was saying, that you have to adhere to some restrictions.
Yep.
And sometimes you have to call one to know if it's okay to call the second.
Sometimes you have to call one to know if you can call the second, because sometimes you have some access functions that have preconditions. Yes, and we will get to that.
I respectfully disagree. But with respect, all the functions have preconditions. In this case, the precondition is true. I'm not quibbling. You can go back through all the literature, all the way back through to Tony Hall. There was no me about 50 years ago for this one. It's definitely the case.
So,
Preconditioning.
okay, so
there's a couple of really has any conditions, they always have preconditions.
Yeah.
Sometimes it's not stated, and at this point I refer you to Kate Gregory's talk yesterday.
Yeah. Okay, so Kevlin corrects both me and John that we have a precondition on all functions. In this case, the precondition is true, which is kind of meaningless, but it is a case. Let's go on, because I only have 75 minutes left. Pushback. Do we have preconditions on pushback? Available space. Someone else? It actually sort of depends on what behavior I want. I have a choice here. Remember, I called it design by contract as an interface design principle. I have a choice now to say, what do I want to happen? What is the behavior I want from push on a full ring buffer? I can say that I want to change say I want to throw an exception. I can do that, or I can return something that tells whether it succeeded or not, or if it's meant to be readers and writers from different threads, I can choose to block. That is a possibility. Or I can choose to make it illegal. I can make it a contractual obligation to not call pushback on a full queue. It's a design choice. Since this talk happens to be about contracts, I choose to make it a contract obligation. So I'm saying that we require that the size is less than n. And here we have this case where one function has a precondition that requires us to call another function to find out, in this case, size. Requires is the terminology used by Björn Meyer in the Eiffel programming language. Pop front. Do I have preconditions on pop front? Sorry. It depends, yes, correct. Gold star. So again, it's a design choice. I can change the signature to return an optional T and say it's perfectly okay. You get nothing if it's empty. Or I can block and wait for someone to push something. Or in my case, because I'm a boring person, I decide to say that you shouldn't do that. It's a contractual error. So you must not pop on an empty buffer. So that is what I do. I say a precondition requires that size is greater than 0. Anyone confused? I blame the spotlight on me not seeing any hands. Postcondition. The postcondition is a guarantee from the implementation regarding the effect of a legal call, meaning that a call that is made in violation of a precondition, then the implementation is by no means bound by the postcondition. Because we are already outside of the bounds of the contract, we can do anything. A postcondition usually refers to return value or object state or parameters sometimes, combinations thereof. So what can we say about the default constructor? It has no preconditions. Does it have any postconditions? Ring buffer is empty. That is a good one. Yeah, I think that really makes sense to give that guarantee that a default constructed ring buffer is empty. Again, ensures is the terminology that Björn Meyer used in Eiffel. So we say this. Do I have postcondition on size? Observed state has not changed. I think we can lean on probably on the const there. I don't know how to express non-change, actually, but I guess we could.
That's called the closed frame problem. You can't say, as nothing else changes, because you don't know what the whole world is.
Hubert says that it's not possible to state that a guarantee that nothing changes because something always changes. If nothing else, time has passed. Sorry? Size between naught and n, yes. Where that is a choice. There are reasons I'm not making that choice here, but it is a valid choice to say that it must return a value between naught and n. Yep. But I'm actually choosing to not have any postcondition.
Postcondition is true.
Kevlin corrects me again, saying the postcondition is true. Yeah.
It's postcondition that the return value is the size of the ring buffer.
Alistair says the postcondition is that the return value is the number of elements in the ring buffer, and I agree, but I have absolutely no idea how to express that, because the number of elements, the way to query the number of elements in the ring buffer is to say that it's size, so the return value of size must be the return value of size, which is not very helpful. But it is true, yes. Can you say again?
It is an essential component of that contract stated in English that there is the value.
Okay, sure, I agree. Alistair says that I can phrase it in English for a human reader to say that this is the case, but I have a hard time formalizing a contract that can be checked by the program itself. John?
When we talk about contracts, are we talking about contract checking, or are we talking about contracts with people?
That is a very good question. John asked, are we talking about contracts for people or contracts for checking? Hang on a second. My focus is on contracts for checking, but since your question came up, I decided to answer. Yes?
Could you explain for me the difference between behavior and contract?
The difference between behavior and contract. The contract is a guarantee that we can observe. How we observe that is unimportant, because this is a part of the interface, but they are linked. The contract is about the behavior, because we want to observe that something we expect to happen happens. No. Okay, so the reaction is that what is the behavior of size? Size does not have a behavior, but the contract is on the whole ring buffer. This is a clause in the contract, or in this case, the absence of one, or at least one that we choose not to speak of. Can we go on to pushback? Do I have postconditions on pushback? Size increments, yeah, excellent. Yes, it sort of does. No, actually, it does not. I will come back to why it does not soon, but not quite yet. But the old here is also Bertrand Meyer's terminology, that it's the value of the old value of size as we saw it before the call. That is a way to say that size has now been incremented. We could also make use of our freedom to see that we are now in the interface design phase here, so we can make changes. So, for example, we can say that we know what the value we push is. So we can maybe say, introduce a new query function that give me the last element, the back. And we can have as a post condition that back is now the value we pushed. But then, of course, I have to make a precondition on back that we don't do that on an empty ring buffer. And that is perfectly okay, because even if when you push the first element into the ring buffer, it is empty before. But when you return from it, it better have the size 1, so the precondition is fulfilled. It will take a few more clicks to get to why it is always true that it is incremented. Actually, fewer clicks than I remembered. What if an exception is thrown? What do we say about the post condition then? Well, it's like this. The post conditions handles the return. If I haven't returned, there is no post condition, This is the force majeure clause in the contract. We are not bound by it. No, we choose to ignore it, which can be a little bit troublesome because this means that we cannot in a contract express the strong or weak exception guarantee. But that is how it is.
I didn't understand that. Say that again. You can't in a contract express?
The exception safety guarantee, because
You can't check it.
we cannot check it.
Okay, but we can express it to a person.
We can express it to a person, absolutely. But we cannot express it as something that can be checked by a compiled program. But we can definitely say this to the reader of the interface, the human reader of the interface. Up front, do we have post conditions on that one? Yeah, okay, size is decremented. It should be one less. Absolutely. We could, I guess, introduce some front function and say that it's the old value of front, with, of course, a precondition on front. That would work. Now we get to the interesting things. Please refrain from trying to express the full logic of the implementation in terms of contracts. It's often impossible, but even if it is possible, you probably don't want to go there. It's madness. For example, then you would try to express the value of size in the history of pushes and pops, and it doesn't end well. Don't go there. So show some restraint when you're using contract. Clause invariant. This one is super difficult. The clause invariant is something that is always true as seen from outside. When a function can be called from the outside, this must be true. It's perfectly okay to violate the invariant while executing a mutating function, provided that no one can observe it. But if you're calling a callback, then someone can come back, so you better have a valid invariant. If you have a lock-free queue, wow, then you cannot once ever violate any invariant because a call can always occur at any time. And this is amazingly difficult to express well. Something that is always true and is meaningful, that says something about the clause. Because it refers to the state, and it is true also in the face of exceptions being thrown. So we know that it's not, at least not inconsistent, but we cannot really say a whole lot. And in this example, the only thing I could come up with is that size is between not and n, which is not a very helpful invariant. And yes, John.
We have an inconsistency because if that's an invariant, then the post condition has to certainly satisfy the invariant, no?
Excellent observation, John. So John has said that this is an inconsistency, and he is absolutely right. And I am guilty of causing that one, because the value of size is meaningless if the invariant isn't true. So how can I check this? Thank you, John. That is a good one. A moved from object. That is one of the reasons. It's difficult in other languages, but it's supremely difficult in C++ because of this. What if we implement this ring buffer in terms of a vector, and what is the state of a moved from vector? Valid but indeterminate, so it doesn't mean anything. So invariants are super difficult. Templates. You may have noticed that this is a template. What about doing a partial specialization, one for pointers? Should we maybe make a requirement on pushback where T is a pointer that it must not be null? Alistair?
In general, once you create a contract on pushback, you're going to require that you propagate up a contract on whatever interpretation you're doing on T. So if you're going to push a T, then T is going to have a copy construct or override. The preconditions on that contract, you now need to bubble up into this contract. And this is the specialization.
So Alistair's observation, very correctly, is that the contracts on T bubbles up. So I'm taking, for example, T by value here. If T is something that has contracts on when you're allowed to copy or move from it, then this contract affects also this function. Did I paraphrase you roughly correct? Yeah. Yes. Yes. So depending on how you implement this, in this case, since I'm taking by value, I better either move or copy from it. So those contracts bubble up. That's what I talked about. The thing with specializations is that it's a really bad idea. In general, I'm sure there are situations where it makes sense, but in general, I would say it's a really bad idea to have different contracts on a specialization. Because what about poor generic code that doesn't know what T is? And it needs to abide different contracts depending on T. That's not nice. Hubert?
Specialization is essentially the equivalent of a compile-time inheritance from that point of view. So if you follow the I4 one, which is that you have to meet this we're into list of substitution principle. Thank you, John. So we're into that kind of area where you have to meet the base templates, the specialization, contract, plus the other.
Yes, and I will choose not to repeat that because I'm sort of getting there. So Hubert's observation was that we can see specialization as compile-time inheritance. So the rules I'm going to talk about now will apply. But Alistair? Okay. So a subcontractor, it's not me being funny, it's Bertram Meyer. A subcontractor is someone who we defer the job to that implements this interface. So now all functions are virtual. What happens with the implementation? What can we say about the contracts there? I'm seeing sign language here from Hubert Matthews. It is perfectly okay from a philosophical point of view to have a subcontractor that has more relaxed preconditions. It accepts more and stricter postconditions, because someone who knows exactly what the concrete class is can make use of that. But someone who is calling via this interface is still good, because a wider precondition is within the contract rules of the base class, and vice versa for the return values. If the proposed conditions are stricter, then it's okay, then they're all within the rules. So we're fine. So why bother with this exercise? Well, I think it can make interfaces much clearer, and I'm not talking about now only when you read the existing interface and start writing your program for it. I also mean when you're actually designing your interface, you can discover discrepancies, inconsistencies in your interface while you are trying to figure out what it should look like. And you express that then later, much clearer for implementer and user. It can make debugging easier, because a contract violation is by definition a bug, and it's pretty clear who the faulty party is, almost always. And it removes a lot of defensive checks, because you know much better what states and values are okay. You don't have to do runtime checks to see, oh, if this is this null pointer, then I must defensively return or whatever. It's not needed. So if we do have a contract violation, we have this detective story that is extremely uninteresting because it's elementary. If we have a precondition violation, who is the guilty party? The client. We have a bug in the client. A postcondition violation, provided that we don't have a precondition violation. Who is the guilty party? Implementation. Yes, you're getting this. Invariant violation. Implementation. Yes. Or we have a really bad contract that states something that it shouldn't state. I mean, we can't say that the next call to malloc must give me exactly this address. It's not a good contract. Or we can say something that the next call to high resolution clock : now must be this time point. It's a very bad contract. It will almost never ever be true. And that's actually it. So when you have, just a second, Alistair. When you have a contract violation, when you have found that this has happened in your code, normally you get the blame game among colleagues who was wrong. And this takes away that discussion, not completely, because you can disagree of whether or not the contract is correct. But it narrows it down a lot. Alistair.
The paradox of the contract is that the contract says the value has to be bigger than 5 and less than 3. In this case, you just never call the function, but then a client tells you they call the paradoxical contract at all. Or is the bug in the contract? Perspectives. Is the bug in the contract or the bug in the developer actually trying to call a function at all? Something that can never be called in the contract.
Is it okay? So if you have a contract that states something impossible, so it is always illegal to make the call. Is it a bug in the implementation that chooses to make the call that cannot be made, or is it a bad contract? It's a judgment call. As you expressed it, where you have a logical expression that can obviously never be true because you have an int that must be less than 0 and positive, then Kevlin.
There's an assumption here that I often notice when people talk about it. There's an assumption that if there is a mistake in the invariant of the implementation, that's not always true, and there are very well-defined cases where it can be the client. The assumption here is that the data is private. Nobody has said anything about that. The original work on data representation invariants did not make that assumption because private wasn't really a thing. So we must be on our guard.
Kevlin has a super important observation here, and that is that when we say that a violation of the invariant is a bug in the implementation, that is provided that no one other than the implementation can actually affect the state. So if you have, for example, public variables, this is not true then.
Or standard memset,
or standard memset, yes. That is actually also one of the things that I'm glad you brought that up. I've used this in a completely different talk. But given that this is C++, we can use memset, etc. But there's no way that we can protect against Machiavelli. So just forget that. And I think memset counts as Machiavelli in this case. But we can protect against honest mistakes. Okay, leaving the philosophy section of this presentation and entering the science fiction phase. A very brief glance in the calendar shows that it's not yet the year 2020. The standard has not been set. So this is speculation that comes from now. There may be changes, we'll see. Here is the draft standard, not today, but as it looked between Christmas and New Year's sometime. One rectangle for every page. The green ones are, in one way or another, about contracts. The last few lines are the index and grammar and such, so we can forget that. And the first one is pretty much table of contents. We have 4 pages here that describe contract attribute declarations and semantics. We have 1 page that talks about contract violation handlers. 1 paragraph about virtual functions that I swear it took me 4 days to read before I understood what it said. And 1 sentence about templates. So, the draft standard is actually a little bit longer now, but I couldn't be bothered to redraw the image. I don't think it has changed substantially. So this is what it says. By the way, these URLs here, they go to the draft standard on a web page, and they give you exactly that clause in the draft. So I'm deliberately using these so that you can look them up if you're interested. So contracts in C++20 are attributes, contract attributes. So their syntax differs a little bit from normal attributes, not substantially. And we see that we have expects, that is a precondition. I understand that at the last standardization meeting, it was voted in a name change to make this pre. But as of this morning, the draft standard still said expects, so I'm sticking to that. So we have expects a contract level that is optional, colon, and an expression. So it can look like this. We have a function template, and we expect that the unique pointer is not null pointer. So that's how you can express it. The optional level is that based on the observation that you can have contracts that are differently expensive to check. Some are very cheap and you may always want to have them on. Some are really expensive and you only want them on in unit test builds, say, as an example. So that's why I have default. They are checked in default builds. So audit are meant for more expensive checks. So you can have if you have audit checks, audit conditions, audit contracts checked, then default contracts are also checked. So you have different levels there. Axiom are interesting because they are actually never checked. What's the use of a contract that is never checked? Sorry? It can be readability. It can be communication to the reader of code. It can be used by static analysis tools. I believe probably we will see support in IDEs that can signal things. Future will tell. Speculation. But yeah, so that's why I have this, and you can then change it. So in this case, I'm changing the precondition here to be an axiom that P is not null because we don't actually want to do the check, but we want to give a static analyzer the ability to check. Yes, John?
This is an extremely, extremely dangerous thing for the topics I'm going to say here. No one should ever, ever use that axiom for that purpose. That is completely a misuse of the tool, completely wrong. You should use it for default checking because that's what default checking is. Axioms are there for when you can't implement it, when it is too expensive to run ever, or when it has a side effect. The word axiom is a misnaming. It should be called hope because you can't check it. It's not an axiom, and in fact, because that's used today, somebody trying to guard against calling a function like that will actually get that elided away, and it will cause a bug. This is a problem in the standard. Axiom is a bad word.
Okay, for the YouTube audience, John says, and I actually agree, that axiom is a poor choice of word, and this is a poor example. What is better is to say that axiom, his example was, it should be called hope. I hope that this is true. And it's actually never, ever checked. And in this case, it's a really dangerous one to have not checked. Thank you again, John. Ensures, similar, it's a postcondition. Again, a vote was made to change this to post. Again, it has not been updated in the draft as of this morning. Also, with a contract level, optionally, an optional identifier, colon, and a conditional expression. So it can look like this. The postcondition ensures audit R. The reason for this R is if we want to express something about the return value, then we cannot name it. But here we introduce a name. We say that when I refer to R in this expression, I mean the value that is returned. So that is how this is used. And then we have assert. And this is, yes? Can contracts have side effects? Technically, yes, it's an amazingly bad idea. Don't do that. Because you can call a function, and who can say what effect that function has? But don't do that.
It says it's undefined behavior. And if it doesn't say it's undefined behavior, it's another fucking mistake.
Yeah. So don't have side effects. Nothing good comes out of that. You can pretty much use these as you use the assert macro, like so. Where I have, instead of the assert macro, I have this one. The difference is that, to begin with, it's not a macro. That is good. And then it participates in the rest of the mechanisms about contracts, how you handle the violation handlers, how they are called, and also that you can choose this contract level.
When is that? Preconditions obviously before, postconditions after, but when is the assert?
When is assert checked? They are checked as they are in the code, as in any assert. Preconditions and postconditions are something you state on the interface. They are outside the, I mean, you can, how do I say this without tripping myself down later? You can see them as not being part of the function. They are something that must be true before or after the function. This one is something that is in the function, that you check at some point. There are no invariants. Does not exist. And to be honest, I think it's just as well, because they are extremely difficult to formulate in a way that is useful. So let's go to this example and C++25 it. That is a word, I just made it up. So invariant, we don't have them, so we might just as well leave it as a contract, as a comment, sorry. And as John observed earlier, it's actually a faulty invariant anyway, because it cannot be checked without violating itself. Ensures. Well, we change it to the contract attribute, say, ensures colon size equals 0. Good. Except this is, I'm really not certain about myself here now. This is, there exists, I'm going to show you that soon. There is a proof of concept implementation forked from Clang 6 that has these. And this compiler says that these are, I cannot call size here because I haven't seen size yet. So contract attributes are declarations that can only refer to what has been seen earlier. I sincerely hope I have misunderstood this and that this is a bug in the proof of concept implementation, but I'm really not sure. If this is the way it is actually specified, I find it to be annoying. Not super problematic, but annoying. So we can flip the order and then everything is okay?
No, fix it, no.
For the YouTube audience who cannot see John shaking his head and saying, no, that is exactly what happened. Like I said, I hope I have misunderstood this and that this is actually a bug in the compiler. If not, I hope it will be fixed in the standard. So, yeah. Requires here. That is not very difficult. We say expect instead, and we're done. The same with front. Pushback, precondition, that is same old. Size, refer to old size. There is no way to refer to the state prior to making the call. Interesting. So we can actually not express this unless we go through hoops and define some really weird function only for the purpose of being able to express this, which I suggest you don't. So what we can do is we can relax this one and say that, yeah, it is definitely bigger than 0. And we can leave us a comment that it's incremented. And then we have another one, back equals t. So this one is interesting. So to begin with, we see here that if a function has multiple preconditions, their evaluation, if any, will be performed in the order they appear lexically. Okay, good. If a function has multiple postconditions, their evaluation, if any, will be performed in the order they appear lexically. Okay, we have 2. That is good. We're fine. So this is good. This works. But then it goes on to say this. If a postcondition ODR uses a parameter in its predicate, and the function body makes a direct or indirect modification of the value of that parameter, the value is undefined. I have issues with this. Because the validity of an interface declaration depends on how you choose to implement it. There will be questions on Stack Overflow. There will be. I can understand perfectly well from an compiler implementation point of view why this is, because if t is a unique pointer, you can only move from it, and this means that the value that was the parameter does not have the same state anymore. You cannot compare them. It doesn't make sense. So I can understand it, but I sincerely hope that compiler writers will make use of their liberty to add warnings, and we do compile with warnings as errors, don't we? This one, I have issues with this one. So we can say this, but it's dangerous. I'm sorry, can you say that again?
Things that are reported from current into the ring box, a lot of that. That's the string which doesn't exist otherwise.
Yeah, yes, exactly. So to repeat, since we have this this dangerous limitation, it means that we can actually not use, in practice, the ring buffer with these contracts with types that cannot be copied. Copy compared, sure, but that is not a problem because that will not compile if it's not copy comparable. Yeah. Okay. Yes. Yeah. And that is also an interesting observation, that which types you choose to use and which constraints you want to have on the types affects which contracts you can have, and vice versa. Because by having such a contract, I am actually now imposing the requirement that the type must be equality comparable. Alistair?
Problems can be solved by moving from contracting the interface to a certain implementation, and then something like pitfalls experts that could visually available parts of the
Alistair observed that we can fix this by rewriting it and actually not state this as a contract at all, but have if const expert in the function body, and when the operation is allowed, we can do it, and if it's not allowed by the type system, we ignore it, or have a static assert and just give a compilation error. Okay, precondition, same old. Ensures the size. Well, we saw already that we cannot express contracts on previous state, so we can only say that it's definitely now not n anymore, it's less. And the same way, we cannot express the old front here, so we can leave it as a comment if we want to, so that's information to the human reader, but we cannot state anything to programmatically enforce this in the compiled code. So that is pretty much it. Virtual functions. I'll choose to cut a little bit here. But if an overriding function specifies contract conditions, it shall specify the same list of contract conditions as its overridden function. So this, one moment, Alistair. This idea I mentioned earlier on from iPhone, that you can have wider preconditions and narrower postconditions, does not apply to C++20. It must be the same. Otherwise, it is considered to have the list of contracts from one of its overridden functions. So my interpretation of this is that you may write exactly the same contract again, or you may write absolutely nothing at all, in which case you inherit the contract, or you have a malformed program. Alistair? Okay. Function pointers and contracts. This is, I think, the most interesting clause about contracts at all, because this says everything about how it works. A function pointer cannot include contract conditions. So this example at the top does not compile. It's illegal. We cannot have that. So, observation, we cannot impose contractual obligations on a callback. This is an interesting one. And then we see that we have this function G that has contracts, and we have a function pointer PF. It's perfectly okay to assign PF to refer to the function G. And it's okay to call it, and the contracts will be checked. So this means that it's the responsibility of the generated code for the function that has contracts to check them. They are not checked outside the function. They're checked inside the function. Otherwise, the function pointer example would not be able to check the contract. And this actually matters. We'll get to that very soon. But we can look at the example. Yes.
What collisions?
Sorry?
What
What about callables like function objects? Well, the contracts are not part of the type system, so we cannot express a contractual condition on a stud function, for example, or a function signature. It does not apply. It is not possible.
So since we can use the function pointers to, let's say, erase the contracts, that means that if we roll our own v-tables, we can sideline the rules of the standard.
If you roll your own v-tables, I would say that you always sideline the rules of the language. But you're not actually, you're not avoiding the contracts, you're just hiding them. They are checked. But let's have a look at an example. Like so many have said, it's a C++ conference. Of course, we have some God bolting here. So here is a not super clever implementation, but that is not the thing. But we see here an interface I think you agree that you are familiar with, and an implementation and a very bad function f that defaults and then calls back, which it's not allowed to do. And we can see this function f here, how it's calling the default constructor and it's calling back. There are no checks being made here. But the implementation of the ring buffer calls size, checks if it's 0. If it's not, it calls terminate. I told you we'd get back to assassinations. And likewise with size, we see that it too checks that the value is what it should be, otherwise we call terminate. Sorry?
What were the contract types on the left?
What were the contract types? What do you mean? The contract level, you mean? They are default. I'll come back to that. But now you have had a brief glance of how the code is generated, yes?
This example we see it calls terminate. Is that something that you specified in the standard, or could we expect a contract violation exception? So at least we can do something.
Is it mandated to call terminate? Yes. Can you call? Can you throw an exception? There are two things here. One is that you really don't want that, because a contract violation is a programming error. And I would really like to see the programmer who can catch a programming error and undo his error and then continue. I really don't believe in that. Alistair is waving like crazy in the corner. It's called a test runner. Yes, that is true. It's called a test runner. So you could imagine situations where you want to test things. Long jump. You didn't hear that. Good. But there is also a technical reason why it's problematic, because if a contract is violated in a function that is no except, we saw that the checks are made inside the function body. That if you have a violation handler that throws, which you may have, that is actually legal. This means you throw from a no except function, which leads to terminate anyway. John?
Best practice is not to do that.
Best practice is not to do that, yes, I agree.
Specifically, don't make a function that has a narrow contract, no except, unless you have an overriding reason to do it like swap.
You're not one of those who believe in context for everything. Sorry, my bad, Blaine blowout. Erase that. It didn't happen. So, let's go on to the topic we just discussed, actually. Policing contract. a lot of text. A translation may be performed with the following build levels: off, default, or audit. A translation with build level set to off performs no checking. A translation with build level default checks default contracts, and a translation with build level audit checks both default and audit. The mechanism for selecting the build level is implementation defined. The translation of a program consisting of translation units where the build level is not the same in all the translation units is conditionally supported, meaning that a compiler or a build system may support it or may not. They have to document if they don't support it, but they may not support it. There should be no programmatic way of setting, modifying, or querying the build level of a translation unit. This thing with different levels in different translation units matters with understanding what happens with when you make a call across translation units. Because as I mentioned, the checks are made inside the function body, if any. So if you have one translation unit that is compiled with the checks off, making a call to a function in a translation unit with checks enabled, be they default or audit, the contracts will be checked. So that is important to keep in mind, and vice versa. Yes, John?
Something even more important, if you have template functions or inline functions, they will not be in the call of the component, but in the client.
Yes, inline functions and templates, since they are in this, we can call them inline in this context, are actually part of the translation unit from the caller. So they will be following the rules of the build of that translation unit. So we can have a look at this. This fork has a flag to set the build level, so we can go back to it. And just to make a difference, I can say that we check this one as audit. So we see now that the ring buffer default constructor actually doesn't check anything. But if we change it to audit, we see that now the checks are there. Or if I set it to off, we have no checks at all. So, continuing, what happens when contracts are violated? We saw calls to terminate. Repeat again, please.
Sorry, how can you ensure conditions on return values?
How do I ensure conditions on return values? By using a postcondition where you give a name to return and refer to that name in the contract expression. So that is perfectly okay. It's not a problem. Yes?
How do you ensure postconditions in multi-threaded environments?
If that happens, you have a data race and you're a bad boy. So the question is, well, how do I check post conditions in a multi-threaded environment? To give a more fair answer, a post condition on a return value is absolutely no problem whatsoever. A post condition on state is. So you have to be careful about that. You have to know when it's possible to express what. Did that answer your question? Kind of, okay. But like I said, if you have, say, a a lock-free implementation, there is no way you can have neither preconditions nor postconditions that refers to state, because the state can change it at any moment, always. But you can have pre and post conditions on parameters and return values. Okay. The violation handler of a program is a function type that is optionally no except and accepts reference to a constant contract violation. Contract violation is a type that looks like this. We have some information about the file and line, the name of the function, a comment, and the assertion level. This no except optional is, like I mentioned, it's interesting because if you do throw, you may find yourself having problems depending on. The violation handler is invoked when the predicate of a contract evaluates to false, so it's a contract violation. There's absolutely no need to call it when the contract is when we are within the bounds of the contract. There shall be no programmatic way of setting or modifying the violation handler. Oh, cool. If a precondition is violated, the source location is implementation defined. Implementations are encouraged but not required to report the caller site. Let's have a look. This proof of concept Clang fork has a contract violation handler flag where we can give the name of a function. So we can try this one. So here I have a violation handler now that just calls write. I'm choosing to use write here because IO streams brings in so much clutter in the assembly. We have the same thing. Everything else is the same. So we see a lot of information. I'm using O1 here because if I can do that just for fun, just so you see. If I use O3 here. What? Oh no, has my compiler explorer died? Ah, bummer. Okay, we cannot see this, sorry. What we can do though is another thing. We can look at it from the debugger perspective. So we have a contract violation handler here. We have a main that very clearly violates our contract. So let's set a breakpoint at my violation handler and run this program. So I'm stopping. We can look at the variable v, or the parameter v, which is the violation handler. So we can see line 21 file contract1.cpp, very imaginatively. The function back, the comment is it's the contract size greater than 0 that was violated. And we can see that the contract level was default. Line 21 is interesting. That is here. So it says an implementation is encouraged but not required to call the caller, give the location of the caller. This one chooses not to. It calls the interface. This is a proof of concept implementation, so don't worry too much about it. And it will call terminate. So if we can, we can look at the backtrace. So we see that main calls the back function that calls a built-in violation handler that calls my violation handler. And if I set the further breakpoint, add, terminate, and continue. So we see the output here from the my violation handler. And the backtrace shows that after it returned from my violation handler, the built-in violation handler calls terminate. So we have a little more. A translation may be performed with one of the following violation continuation modes, off or on. A translation with a violation continuation mode set to off terminates execution by calling the functions to terminate after completing the execution of the violation handler, as we saw. A translation with a violation continuation mode set to on continues execution. And there is an example. So depending on how this call to F that is clearly in violation of the contract, this may or may not cause termination of the program. And here we get to the possibility of Alistair's example for testing, that you can get a call to your violation handler. You set continuation mode to on, and you make sure you do something in that handler so that you can observe what has happened. John?
This is not the reason for continuation. You can always throw an exception and check your code that way. You can also long jump.
Yes.
You can do a lot of different things. The reason for continuation is specifically when you introduce contracts into existing legacy code, and you want to observe whether it's being called down a contract without bringing down the production program.
Yes, I know, because it's written here that the reason for
but not for testing.
Not for testing. Well, okay, yeah. John's observation is that even though you can use this for testing, that is not the purpose for having it there. The purpose is for being able to add a bunch of contracts to existing code and observe what happens. Observe if you do have contract violation in a program that, as far as you know, behaves correctly. And that is actually pretty much what I had to say. I just want to briefly summarize this. In my opinion, design by contract is a way to clarify responsibilities between a function implementation and its callers. Language support is, touch wood, coming to C++20, but it's lacking class invariants. Postconditions cannot refer to pre-call state. We have some interesting gotchas, like this modification of a parameter and template specialization. Actually, that one paragraph in the standard that says something about templates and contracts actually says that a specialization is a completely new thing. I don't know. So you're free to do something amazingly stupid. Please don't use that freedom. Contracts can be used by static analysis tools, IDEs, the optimizer, but that is not just a little bit controversial. You can have configurable levels of contracts. So you may have, you can express your contracts at different levels, and you can choose to check them at different levels. And in my opinion, prefer, if possible, to use type semantics instead. And please do play with this fork if you want to. It's pretty brittle. It's very easy to get internal compilation errors, trust me. But it gives you an idea. I have been told that there is a GCC branch that also implements contracts, but I have failed to find it. So I don't know.
Andrew Sutton is working on it with me.
Andrew Sutton is working on it together with John Lakos. There is one in online Godbolt that is a bit flaky also. Well, so you have two flaky implementations. And that is all I had to say. Here is how you can choose to stalk me if that is what you like to do. Thank you very much for listening.